In 1911, the British physicist Ernest Rutherford published a paper that was to revolutionise science. Rutherford's famous alpha particle scattering experiments transformed our understanding of the atom, and it led to the development of new areas of physics, including the theory of quantum mechanics. The work was carried out here at the University of Manchester, where Rutherford held the chair in physics for 12 years. To celebrate the centenary of these landmark experiments, the university is hosting a special week-long conference organised by the UK Institute of Physics.
Well, when Rutherford was working here at the University of Manchester, he set his student Ernest Marsden and his assistant Geiger to make a measurement of the effect of alpha particles firing a thin foil of gold. And that experiment was actually done in 1909, and it was published. But then it took 2 years for Rutherford to actually understand what that experiment meant. What he realised that it meant was that there was a very tiny nucleus, although he wouldn't use that phrase at the time, but there was a tiny dense core at the centre of the atom, and that overturned the sort of prevailing picture that atoms were solid objects, if you like.
So he wasn't, I mean, these experiments, he wasn't doing them in isolation, he had lots of colleagues. I mean, what was he like as a scientist by their accounts?
Well, it's very interesting because we think of physics now being a hugely international subject, but actually Rutherford was extremely well travelled at that time because he was from rural New Zealand. He studied there, then he studied at Cambridge, then he became a professor in McGill University in Canada, and then he came back to Manchester and then latterly to Cambridge. So really he travelled all over what was the British Empire at that time. And so he was a very international scientist. He also collaborated very much with people across Europe, the Curies, all the other people who are working on radioactivity. And of course they corresponded by letter, not by email like we do it now. But I think they were equally able to collaborate and meet all. You see famous pictures of Rutherford at these Solvay conferences standing next to Einstein and all these other people. So
he was already a very eminent scientist.
Yes, and what's very interesting actually about Rutherford was that Rutherford received the Nobel Prize for Chemistry in 1908 for his early work on radioactivity and explaining what alpha particles were or what alpha decay was. And he actually did his most famous work, which is showing the structure of the atom, after he received the Nobel Prize. So it's one of the few scientists who actually did their most famous work after they received the prize. And he also received it for chemistry, which might seem strange because we would claim him as one of the 20th century's greatest physicists.
So would he have described himself as a chemist or a physicist?
Well, there's the famous story that when he received this Nobel Prize, he said that he'd seen many transformations in his laboratory, but none so rapid as himself from a physicist to a chemist. So I think he was vaguely amused by it, but also probably very pleased with the honour, so he wasn't going to complain too much. But yeah. I think in those early stages, people probably saw that subject much more as being chemistry and, manipulating elements and substances and so on. And nuclear physics as a subject, you would date it, I would say, to 1911 and Rutherford's work, and then perhaps it became more seen as physics. But in those early days, it was perhaps chemistry as much, which is interesting.
I mean, are there any other areas of physics which simply wouldn't exist without this discovery?
So one of the big impacts has been in medicine. So understanding the nucleus and radioactivity has led to many diagnostic techniques for present medicine, like positron emission tomography and so on, all of the radiotherapy, the cancer treatments that people receive. So really all of that you could draw back to the early work of Rutherford.
Another nuclear scientist presenting at the conference is John Schiffer. Let's go find out his thoughts on Rutherford's big discovery. you think would have happened if Rutherford hadn't made this discovery?
Yes, well, that's an interesting question, and it takes us a little bit beyond physics. Undoubtedly, sooner or later, somebody else would have made the discovery. But this was in 1911. Would have somebody made it before the First World War? Certainly nobody would have made it during the First World War. Society was occupied with other things. My guess is it probably would not have been done till after the First World War. Now, that would have delayed the development of science, but there could have been other consequences. Fission probably would not have been discovered before the Second World War. The question is then, if you start speculating along these lines, is probably would have been discovered after the Second World War, but the lessons that were learned in the Second World War in Hiroshima and Nagasaki would have been not there. Would the Third World War have been avoided then? Would the nuclear war have first use of nuclear weapons in a war been in the Third World War? You know, you can write science fiction books about that. I can speculate, but I have no idea.
So when he's presented this new idea, I mean, at that time, did people really appreciate the significance? I mean, did he appreciate the full significance?
Well, I'm not sure about the full significance, but it had an impact rather quickly, because Niels Bohr was a visitor at the laboratory at the time, and he developed what essentially now we know as quantum mechanics on the basis of a picture of a nuclear atom and explaining atomic spectroscopy that was known. So much of 20th and 21st century physics is quantum mechanical, and the start of quantum mechanics was in Rutherford's discovery.
It's not just professional physicists who are celebrating the centenary of Rutherford's discovery. Manchester's Museum of Science and Industry is also hosting a special exhibit about Rutherford's work and his legacy to the city of Manchester.
Well, we're very lucky to have been able to borrow quite a few items from other people, and it's here until November. We've got Rutherford's desk and chair that he used at the University of Manchester. We've also got some items from the Cambridge University Library. So we have a lovely letter from Niels Bohr writing from Copenhagen saying how much he missed the lab, and would Rutherford please do an experiment for him, or get somebody to do an experiment for him. We've got one of Rutherford's notebooks that was used during the disintegration experiments, and we also have that disintegration chamber as well, the very original one. We've got a few just generic lab pieces which we borrowed from the University of Manchester that we used in Rutherford's lab. So we have an electrometer and a resistance box. We also have Schuster's visiting book. Schuster was Rutherford's predecessor, and he essentially brought Rutherford to Manchester. He personally invited him. He kind of made sure he got through the selection process, paid quite a bit of his salary as well.
So were they close friends? They were
yes,
close.
Yep, they were close friends, and they did lots of holidaying together and that kind of thing. And this visitor's book is from Schuster's house, and you can see all the visitors' signatures. So you've got Ernest, his wife Mary, and I think on the same page you've got James Chadwick, who was a very good friend of Rutherford's in the end.
So was he quite a dominant personality, do you think?
I think he was a strong personality, and I think without that strong personality you couldn't have directed all of those experiments and kind of created such a stamp on the field as he did.
Yeah, absolutely. And also, I mean, because he obviously lived around the world. He's born in New Zealand, spent time in Canada. What was it like coming to northern England? I mean, we know how much it rains here in Manchester. It
does. He seemed to quite like it. I mean, he ended up with a holiday cottage in North Wales, which again possibly isn't the sunniest place in the world. But I think he settled fairly well.
So there you have it, Rutherford's discovery of the atomic structure had a dramatic impact on science and technology over the past 100 years, and it looks like this discovery is set to shape physics over the century to come.